Well, it involved a lot more drama than I expected and an extra computer, but I finally got my first good nerd story to share with y'all. I'm going to continue to mention Dave Plummer and his channel on here. I feel a lot in common with the guy, even though I can't point to billions or even hundreds of deployed copies of the code I've written over the years. Throughout my various jobs, I've been everything from a single person IT department for a small company to a developer on a small team to a developer on bigger teams. But all the work I've done has mostly been in vertical markets: point of sale, did some power monitoring, workforce training management. Then I got into some .com era web app stuff, early web app stuff. But no matter what the team was that I worked on, there was very little chance for notoriety outside of that little silo that we were in. And by the time social media came around, I was well into a career at a company that really valued its privacy. And there were so many risks for being in the public view. I never bothered to try and establish any kind of early social media presence. The extreme social stuff gets in my way anyway, and there's the whole negative self image thing and all that. Anyway, in one of his episodes, Dave talked about the scroll lock key. I'll put a link to that episode in the description. The scroll lock key is the seemingly vestigial part of the old IBM PC keyboard that honestly didn't seem to do anything. You could figure out what to do with it, and if your application supported it, it was actually pretty powerful. I kind of know all about that key, albeit for one of the dumber reasons imaginable. Um, when I was teaching myself as much as I could learn about early PC architecture, I found this book by Microsoft Press called the Programmer's PC Source Book by Tom Hogan. And it looks like my copy didn't make the cut when I moved a few years ago. I studied both volumes 1 and 2 of that book to the point that the covers were held on with duct tape. And buried somewhere in those pages is this rudimentary map of the old IBM PC BIOS x86 architecture. And I remembered that there was a single character that held the status of these modifier lights, as they were called: num lock, caps lock, and scroll lock. Hey, hold on. One character? That can't be right. Don't you mean one character per key? No. Look, on those old computers, 640K wasn't a lot of room to begin with. And so engineers looked for every efficiency they could find. I could recall the memory offset off the top of my head where that part of the BIOS gets loaded. It was in 0040, but I got the offset wrong. For numlock and caps lock, the OS handled those modifiers just fine. But if you wanted to deal with scroll lock, that was up to your program. And for most text-based programs, or even anything early with a true graphical interface, it didn't matter a whole lot, except to people using spreadsheets. Excel and Lotus 123 use scroll lock pretty powerfully. At some point, I invented this need to programmatically toggle these lights, and so I set about writing a quick utility. I think it had something to do with making sure the caps lock key was always on. I forget, but whatever the reason was, I created this thing and set myself out to solving it. So DOS came with a program called debug.exe, and I'm going to show it in the demo in a minute. By itself, it could be kind of intimidating. It pretty much is just this hyphen prompt staring back at you. But I got quite adept at mucking around in assembler to the point that just for fun, I wrote a stupid utility that would put a series of values into the right memory location that would toggle the num lock and caps lock and scroll lock lights. So first they would pan from left to right, then right to left, then they would blink in unison, and then they would return to their original state. And I wrote the whole thing in assembler, except for one thing. Even on slow, old 88 computers, there's not a lot going on. So that program actually ran too fast. It successfully completed before anybody's human senses could detect anything. So after a really short period of WTF, where the program just dropped right back to a DOS prompt or a C prompt, I, I just decided, you know what, I'm just going to go through this thing one by one. And as I went through it, line by line, I found that the assembler was doing exactly what it was supposed to do. It was caps lock would be on, then it would be off. It was easy. I could look at the lights right there with me. Do you know how hard it is to write a delay in assembler when nobody else around you knows assembler? It's not easy. And it was getting to be really hard. So I was a couple of hours into this way to figure out how to write inefficient assembler code when I had this sort of moment that maybe a higher level language like C, where I could more easily build in a delay, maybe that would be a better choice. Sure, the base code still ran lightning fast, but I'd found this way to wait for just like a quarter of a second, just long enough for humans to perceive the change in the light. And I thought, that was fun. So I kept thinking of other fun things to do just as this way to pass the time. I wrote this routine that would print barcodes in the most efficient way possible using 95 bytes of memory. In my first job, we wrote code that worked with a lot of product barcodes. It was retail point of sale. And we were kind of always needing to fake inventory items out. So I wrote this code that would just print a barcode, and it uses something called 3 of 9 encoding. And I would just print out sheets of barcodes for testing. Now, why only 95 characters, you ask? Well, in the early days of the PC, as I mentioned earlier, there was this constant need to effectively manage memory. I will carry information I learned about optimizing people's config.sys and autoexec bat files with me for the rest of my life. And so by writing a super optimized barcode generation utility, I felt that I was kind of like proving myself and my skills to not only to myself, but to others. I titled this podcast Nobody Cares, Dude, for a reason. I remember stuff like that 3 of 9 encoding, which basically means every UPC character is made up of 9 elements. There are 5 dark lines and 4 white lines. And 3 out of those 9 elements are wide. So depending on the way it worked, you could either have a wide black bar or a wide white space. So 5 of the lines are black, the other 4 are not printed. So I converted every single UPC character that we needed to deal with, which was numbers and letters, into a number that could be stored in just 9 bytes. So the odd numbered bytes are the black printed elements, and the even numbered columns were the spaces. The last space in the element was a fixed width blank. So, for example, the character 0 represented as a decimal is 46 because the 4, the 16, and the 32-bit positions represent the wider elements for that character. I'll put a really terse Wikipedia page explaining this, but hopefully you get the drift. It's not worth too many cycles. Nobody cares, remember? I stored all of this in this array that I managed with this lightweight wrapper, and I had myself a little fine utility that served me really well. So I used a recollection of that code to fix a problem with a PeopleSoft installation 15 years later. In the PeopleSoft example, I was a lot less worried about RAM, so I handled it in a more logical and expeditious way, though I did write it in Java, and there's nothing logical about that language. But I digress. So here's what I'm going to do. Okay, so I'm going to reboot here just so everybody can see what I'm doing. And what you'll see is a regular IBM PC startup sequence. Looks pretty common. This particular emulator is based on the MS-DOS 6.22 setup disks. This was the last full version of DOS, as it would be called. I will talk about Windows 95 in a future episode and how it was really Windows running on top of DOS, even though Microsoft didn't want you to pick up on that. But it's unimportant to the conversation right now. Microsoft, you put DOS 622, you boot up, you get the setup program. I'm going to exit out because Microsoft was nice enough to include everything we needed on this one disk. So if I do a directory, you'll see that there are some files on here like edit.com and expand.exe that just look like normal, regular old DOS files. But then you'll see like mem.ex underscore and replace.ex underscore. Those files are actually compressed. It's a very lightweight form of compression. It uses the command that you can see on the screen here called expand.exe. We're not going to worry with any of that. The only thing that I'm worried about on this disk is right here, debug.exe, and that's what we're gonna mess with right now. So let's start with a nice clean screen so everybody can see what's going on, because it's really going to be unimpressive. If you go to debug, boom, a hyphen prompt. Oh my God, there's nothing else. What am I doing here? And if I do a quick help, okay, I can assemble things. I can compare address ranges. I'll get into that at some point. I can dump address ranges, and that's really what we're going to work on the first time. And I can enter address ranges, and we'll do that in this excursion here today. I'm not going to mess with any of the other stuff today. Just want to show you that it's there. But today we're going to focus on the dump command. And I had this, I mentioned it earlier, the PC source book. It had this great table, and it just showed the BIOS. And the BIOS, is kind of unimpressive, but the one character that we need to worry about is 0040, and the offset is 0017. I'm not saying 17 because it is not 17, it's 17. This is base 16, so it is not 17. 17 is actually 1 1. 10 is 16, 1 is 17, but this is offset 0017. Okay, I'll shut up about that now. All right, so I talked about the caps lock, num lock, and scroll lock. So I'm going to go ahead and turn all of those on. And really, the only thing I can demo to you here, this thing comes with this awkward keyboard. I can show you that with num lock on, this produces a 2. But if I go up here and turn num lock off, the exact same key does nothing. It's just one of those quirks of the IBM PC back then. But all right, so if we look at 00, turn all my lights back on. If I look at 0040, 0017, I see that it's a 70 now. And what does that mean? Okay, well, I'm going to cheat a little bit. The 1 bit for this, and this is stored, I think I'm going to say this right. This is big endian, which means the most significant bit is stored lower in memory than the least significant bit. So instead of looking to you like 07, this looks like 70. None of that matters, just so you know. But what it tells me is there's a 4-bit, a 2-bit, and a 1-bit. Okay. So if I turn off the 4-bit, that would leave me with a 30, which, if I remember the order right, scroll lock is 1, num lock is 2, and caps lock is 4. So if I go in to enter mode and I set this to, let's just say I want to turn caps lock off. Okay, so I'm going to subtract 40. So I'm going to turn it to 30. And see, it's set to 30 now. When I type, my keys are not in all caps anymore. You see how there's a capital D there and a capital E here. I'll put it back and I'll show you. See? All uppercase. Lowercase. So that's it. Thanks for indulging me on that. It was interesting and fun to kind of go back and do that. I didn't call it out in the demo, but I pay close attention if you want to go back and look. None of the modifier lights on the emulator that I was running ever changed unless I clicked them. And I was going to call that out, but it got out of hand. But basically, that's the difference between an emulator and running on real hardware. And I just want to call that out before I signed off. So thanks for listening. Take care.